Good morning to everybody. Good evening to everybody. I don't know where you're logging in from or where you're watching, but statistically, it's probably sometime in the morning for you, maybe early afternoons. I appreciate that of all the places you could spend your time right now, you are spending it with us. That's awesome. My name is Josh Long. I work on the Spring team. I'm a Spring developer advocate, a Kotlin Google developer expert, very important for this presentation. I'm a Kotlin GDE. I'm a Java champion, and I'm at your service. So if you have questions, if you have comments, feedback, whatever, I'm, as always, very happy to engage. Now, we're going to spend our time today talking about Kotlin, which is a language that I love, and Spring, which is a technology stack that I love. And I think these things work very nicely together, right? They are natural combinations, or natural combination, or a natural pair. Let's talk about Kotlin. Now, Kotlin, I don't know what one single feature I could point to make clear that, you know, Kotlin is interesting, right? To me, Kotlin has become this amazing thing that is represented not by any single thing in the technology, but it's represented by the community, right? And the community is where really I think the most power comes from when it comes to this programming language, and the ecosystem, and the people that work on it, and the team that work on it. They are pragmatic, very, very pragmatic, and that has made it so that the language has become a natural way to build applications, no matter what the nature of the application, no matter what the style, and that has become really powerful. It has meant that, as a result, Kotlin has become a great way to build desktop applications, to build mobile applications, to build server-side applications, to do build files, right? Just to, you know, for Gradle. It has become something that is useful in all the different aspects of the ecosystem, instead of having a very strong opinion about any one particular part of that ecosystem. So I love the pragmatism. I love how flexible and how approachable the language is for people in different ecosystems. One thing that strikes me as a person who loves Java, but who loves Kotlin as well, is that the Kotlin language, the team that work on it, are able to get a lot more done very quickly. And there's some good reasons and bad reasons for this, of course. But one of the reasons that that it goes so fast is there's just one really core team surrounded by open source, right? And so they're just moving in response. And so they can afford to move quickly, and they can afford to build things that are going to, you know, support different use cases directly. And it's just different. It's just very different from the Java experience. Java obviously is growing very quickly, very nice language, but not as quickly as Kotlin, right? I don't think there's any disagreement with that. And it also has the benefit of being a brand new language. So when it was created, the goal was not to use Kotlin for applets, all right, or for embedded firmware. It was meant to do sort of a little bit of everything that Java does, and maybe just make it a little bit more pleasant. So I've found that the team that work on it, the people behind it, and the community behind it are one of the biggest features of the language. So I love the language, but as with all things, it's important to consider the context. And so when I was invited to go speak at the very first Kotlin Conf way back in 2017, it was in San Francisco. You can't tell, but I live in San Francisco. It's dark outside. It's midnight here in San Francisco. And I was excited about the opportunity to come speak at this Kotlin Conf because I thought, how nice will it be to go home, right? I'm usually, back then, before the virus, I used to travel. And it was very nice to me to have this opportunity to fly to San Francisco and to go home, to see my home. And I was very excited about that. So I said, yes, I'll be there. I'll be there, no problem. Don't worry. And I got to this conference, very little marketing, very sort of like, it was the first time. I wasn't sure what to expect, but I was thinking it would be a very small group of people working on this nice little language, and it would just be nice, you know. I was wrong. I mean, it was nice. It was definitely nice, but I was wrong about the size. The conference was huge, right? More than 1,000 people the first installment, right? Huge conference, very, very crazy, wonderful, passionate community that turned up. And I look back now, and it is very clear what happened, right? It's very obvious to me what happened. I was invited to speak at this conference in 2016, and in between when I was invited to speak before the conference was announced and when I arrived, Google I/O happened. Google I/O is this big event for Google, and Google ecosystem developers. And there, the Kotlin team and Google announced that Google officially supported, they didn't recommend, but they supported using Kotlin on Android. Big deal, right? Because a lot of people were using Kotlin and Android anyway, so a huge community there. And in 2016, the Spring team had already put Kotlin on start.spring.io, which is what you see here. So two big things to me were happening then in 2016. Suddenly there's a lot of people using Kotlin on Android, and that had been going on for a few years. There's now official support for Kotlin and Spring, and that had been going on for a little bit before we actually did it officially. And so this told me that something was happening, right? This language was now getting to the point where people wanted people to use it in their ecosystems, as opposed to it was another thing to support and people were resistant, right? It was really, really amazing to go to that first event. And ever since then, it's just stuck with me that there must have been something, that the Kotlin team did to enable this, to sort of get that kind of attention. And that's been part of the reason I've been such a big fan of this ecosystem. It's pragmatic. So today we're going to take a look at Kotlin, and we're going to look at it in a number of different contexts, because the thing that you have to remember about Kotlin is that it's not just a language for the JVM. Quite the contrary. It's a language for the JVM. It's a language for JavaScript. It can be a better JavaScript. You can do native code. It's a better, you can think of it kind of like a better Go or Rust or something like this, or maybe not a better one of those, but definitely a better C, right? Like for a lot of use cases. So there's just this really interesting opportunity here. And so I don't know where, it's very hard to pick a place to start, but let's do a quick tour, okay? So I'm going to create a new project here inside of IntelliJ. And I got to tell you, I was going through this presentation before we started streaming, and I haven't done this presentation since last year, and this tooling broke. So what I'm about to show you is Kotlin Native. Kotlin Native is a way to build applications that compile to native images, to native code. And the way that this works is that it's using LLVM, the native, the compiler toolchain that powers things like Swift and I thought, well, I'm going to run through this application. I'll use Kotlin Native. Every time I do something with Kotlin Native, the tooling breaks, and that's a little unfortunate because I've been doing this demo with Kotlin Native for a couple of years now, and it seems like first it was in CLion, now it's inside of IntelliJ, and it's not great. I won't lie to you about that. It's unpredictably bad. So I hit next, and no, that's fine. Finish. Wait for that to load, and this is where I got an exception. Maybe it'll work this time. I would love to be wrong. It worked a few months ago before the new year. Oh, there you go. That looks like the error. That's fun. So I don't know what this is. That seems interesting, but it doesn't matter, right? All I care about is this little bit of code, and what I'm going to do is I'm going to show you a program that takes advantage of Kotlin Native. Now, I know we're not here to learn about Kotlin Native, but what I think is so impressive about this is the opportunity here. You see, the most powerful thing for a given programming language is not the syntax, right? I would never change a programming language just to get a different syntax. That's a terrible reason, unless it's like, going from assembler to something very modern and high level. But even there, if you're more proficient and more comfortable in assembler, maybe that's better for you, right? Syntax doesn't make the language. Ecosystem makes the language, and Kotlin does its best to bring you to all of the ecosystems, right? So if you want to write native code, great. If you want to write JavaScript, great. If you want to write JVM-based code, great. If you want to do WebAssembly, great, right? There's options there. And so I just like how they've really worked to make Kotlin this very good choice, no matter what ecosystem you choose. And that means that sometimes the JVM isn't the best fit. Hurts me to say it, but it's nice to know that if I wanted to write code that takes advantage of these other things, I can, right? So what I'm going to do is, since this doesn't work, right? You can see I've got, well, maybe it does it? This is a test. Let's see. let's see, import Kotlin X. No, that's not working great. So what I'm going to do is I'm going to cheat a little bit here with the imports because I don't have the time to manually type out these imports. But basically, what I'm going to do is I'm going to show you a very quick program here, and real programmers, I'm sure, will I'm sure that the real programmers will use Emacs and just laugh at me for not remembering, because again, it's a native language. So maybe you're a C programmer who's just had more history doing that kind of thing, and this is not a big deal. But for me, I need my IDE. I need my good IDE. So I'm going to use the tools that I have available to me here. Let's see. Here we go. All right. So paste. Okay. Now, what I'm going to do is I'm going to build a program that opens up a file. So I'll say fopen, and I'm going to read the data from a path. And the path I'll get from within a function, right? So actually, let's create a function to do that, right? I'm going to create a little function here called fun read lines. And here we can already learn a little bit about the syntax of the language, right? So I've got this function. It's going to return a list of strings. So you can see I've got a Kotlin Native list, and I have a path, and the path is a string, and just, it's got a type system. It's just like Java, except that the types come after the variable name. Not a big deal. It's very similar to a lot of other languages. And in that function, I'm going to create a file, and I'm going to use fopen. And fopen comes from POSIX. This is a part of the low-level contract that languages have with most Unix-y style operating systems, right? And so I can just use that. I'm going to do fopen to read the data. I want to get the lines. So I'll create a mutable list of strings, right? And again, very, very convenient builder there. And then I want to open up some data, but the data I'm going to read is going to be using native functions. So I'm going to get native memory back, which means I need to garbage collect that memory. And so in Kotlin, to make this easy so that you're still dealing with, it's still Kotlin, but now you get the best of both worlds, right? Very, very common. And I get this nice scope, mem scope. It'll just automatically dereference any pointers for me, which is very convenient, right? So
Josh, just a second, please. Sorry that I interrupt you. Our participants mentioned that the font is pretty small. We're able to use presentation mode or a little bit increase the font. Thank you so much.
How's that? Okay, I'm assuming that's fine. Thank you for that. Sorry about that buffer. So what I'm going to do is I'm going to read the data from the file into a buffer, and I'm going to pass in the buffer length. And when I've done that, I'm now going to loop through and just read data, read lines, and accumulate those lines from the file. So I'll say next line equals f gets buffer, and then I'm going to read the buffer length, and finally I'm going to read the file. So what this is going to give me back is not a string. It's going to give me a pointer, a C string. So I need to dereference that and to take from it a K string. So there's these convenient functions on these types that didn't exist there in the native C API. But the thing is, in order to turn this return value into a K string, I need to know that this fgets function returns a non-null value. And I don't know that. And so in Kotlin, you have this nice syntax, this question mark dot. The syntax lets me take the value if it's not null and dereference it. Otherwise, give me a null, right? Which is very convenient. And so now I can say, okay, if next line should equal null, or next line dot is empty, right? So I'm testing whether the line is a string or it's null. And if it's not null, then I want to use it, right? So I'm going to break if it is null, but otherwise I'm going to accumulate it into a buffer. So add next line. Okay, so very, very, typical C code. I'm sure you have written something like this, but there's some differences here still. There's some very interesting things that are different from normal low-level C languages. One thing that I like is I can do try-catch, right? So I have the same control flow options that I have in high-level languages like Java and Kotlin. I now have that here, right? So paste, good. And then here, what do I want to do? Well, I want to deal with the exception, right? So I'll say, okay, actually, I don't want this. I want to do finally. And finally, I'm going to close the file. So file, and there we go. So this is my little function to read the data. And now I just want to read the data, right? I'm going to create a little function here to get the data. So hello, oh no, so reading And I'm going to open up a file, and the file lives on my desktop. I've got a little file here, desktop. Okay, test.txt, hello Kotlin Native, right? So it lives on my desktop, which means I need an environment variable. So I need to get the environment variable called home, but again, that's not a native string, so I have to use 2k string. And that in turn, if it's null, I want to store quote, quote. And so this operator here is called the Elvis operator. It's kind of like a ternary expression where it says, if anything on the left side of the expression is null, if it's not null, then evaluate it. But if it is null, then evaluate this, whatever this is on the right. In this case, it's just an empty string. So I'm getting the case string, and then I'm going to read the lines. I'm going to say, okay, read from home. And again, home is this environment variable. It's this property. It's this variable that I created here. I can do string interpolation. Okay, that's very convenient. So desktop test.txt. All right, and now that I have the lines, I want to print out each line, and I don't have to do a for loop. I can just use the very convenient for each operator, right, in the code. So that's it, my friend. That's a very simple Kotlin native program. You've done something like this before. I'm sure you must have. Let's compile it and run it. I would use the IDE normally, but again, they insist on breaking this every other week, so I will just instead run this, run release executable native. Okay, let's see if that works. So this is using Kotlin and Gradle behind the scenes. What did I do wrong? Type argument is not within its bounds. Alloc array byte var. Okay, seems like a silly mistake. There's not too many more. Oh. Okay, now we have to return the lines. Okay. So this will take a second. This is not exactly instantaneous. In this way, it could use a little bit of improvement compared to something like Go, but it's still very good. So now I go here to the build directory, bin, native, and I can run this, right? Just there you go, hello Kotlin native. So it printed out the result. Are you going to do Kotlin native right now? Probably not, but the fact is you can, right? So all sorts of applications suddenly become possible. You could do like stuff that talks to low-level operating system features and APIs. You can actually import and work with native APIs. That's very convenient. What about mobile, right? Well, of course, you know that Android Studio now has support for Kotlin, and it's had it for a while. And the default is now Kotlin. So I go here, and I can just create a Kotlin application, and I can just, I'm not even going to type anything. It just works, right? So let it load for a second. Hopefully it'll finish before we're old and gray. Gradle project sync in progress. Okay, good. And I've done the right thing. I've already started up the emulator, but let's see if it does the right thing and loads the application here. You can never be too sure. Okay. There you go, a Kotlin application in Android. So again, couldn't be easier to get yourself into an environment. You can see there's tools that support you there. So I like this language. We could go on all day. We could show all sorts of different ecosystems. But what I wanted to talk to you about, of course, is Spring. So what we're going to do here is we're going to build an application at start.spring.io, my second favorite place on the internet. Obviously, my first favorite place is production. And again, that's why I love the pragmatism of this language, is it brings you ecosystems so that you can ship software, not just have nice syntax, right? And so now I'm going to build an application that uses old APIs. I'll use H2. I'll use JDBC template. I'll use, well, I guess that's it, actually. That's fine. Let's just use that. I'm going to use Kotlin, right? That's the important bit. You got to choose Kotlin, otherwise you'll get a Java project. And I'll hit generate, and I'm going to open this up in my IDE. CD downloads UAO basics.zip. Kotlin native, don't need that. UAO basics.zip. Okay. So this application is a normal Spring Boot application, and yet when you open up the main file, a few things are different. And indeed, when you open up the build, a few things are different. When you generate a project at start.spring.io, we automatically add libraries to make it so that you can work with Kotlin out of the box. You don't have to do anything special to get this to work. So you've got your Kotlin dependencies there. You've got the Kotlin compiler lined up here. And you can see there's a plugin here as well. And this plugin is an example of the pragmatism that I talked about earlier, the willingness of the team that makes the Kotlin language, that works on the Kotlin language, to make it the best experience for people, no matter what ecosystem they're participating in. And so one of the things that you'll find in Kotlin is that types are by default final. They're called, they're sealed basically, right? They're final. So in order to make them open, you have to be explicit. You have to say open class foo, right? So I have to open the class. If I don't, it's final. But this is a problem because lots of technologies, including Spring, rely on the ability to extend that class, right? And so we need that to be open by default. Well, this plugin there's a mechanism here called the Kotlin All Open plugin, this thing here. And this allows arbitrary plugins to provide reasons for classes to be open by default. So it's a strategy, and you can plug in different strategies for classes to be open by default. One of the strategies is if you're using Spring, if you have Spring annotations on the class path, then all the normal things that you would do in a Spring application, like using stereotype annotations, like @component and @controller and @rest controller and @service, and if you're using bean configuration, all of these are clues to the compiler that it should make the class open by default. So things are going to just work for you. And you may be surprised at that if you've used Kotlin before in a different context. They'll just work. And I think that's really cool, right? It's just yet another example where the Kotlin team worked with the Spring ecosystem to make this just a great choice for Spring applications. So what we're going to do now is we have a brand new public static void main Kotlin application, and we have a function and we have a class. And the important thing to understand in Kotlin is that the class and the function are separate things in this case, right? They could be the same thing, right? They could be part of this. But when we talk about classes inside of, when we talk about functions inside of classes, we call those member functions. You can call them a method. People will know what you mean, but they're called member functions, right? And if they're a function outside of a class, they're just called functions. That's nice. So we have a class, we have a member function. We are using that array there. We're using the array of arguments, but this is not required, right? In Java, you need public static void main string args. But in Kotlin, if you're not using it, you don't need to declare it. It's just a little small thing, very tiny, but it makes everyday life just that much easier, especially if you're generating your own, if you're writing your own public static void mains. Okay, so we have a brand new application, and what we're going to do is we're going to write data to the database. So I want to create an object to map my data to that database. And of course, I'm going to create an object as a kind of entity. So I can say class customer, and I can have a field like this, and I can say I want to have an integer for a field, and maybe I'll make it a null. But if I do that, you can see the compiler complains. It says you have to be explicit about the fact that things are null. You have to say that things are nullable. So you have to have a question mark. If you don't, then you can't do that. You can do like -1, right? But you need to be very explicit about this nullability. This is another thing that's really nice about Kotlin, is that the compiler cares and it knows about nullability. That's what you saw earlier when I was doing question mark dot and question mark colon, etc. So I could do something like this. I mean, this is technically valid, I guess, but it's not the correct way to go. This is Java, right? This is basically Java. What I'm trying to do is to create a class that has two fields, one for an ID, one for a name. And I want to create a getter for the fields, and I want to have a constructor, and I need equals and hash code and 2 strings. Well, at this point, until Java has records as the main feature, as a part of the GA release, at this point, there's no great way to do this in the Java ecosystem, right? There's a preview feature, but it's not quite here yet. So I could use records in Java in the future, but right now, I would have to use lots of lombok. You just throw lombok on your Java code and you hope, right? That's the strategy. But in Kotlin and in Groovy and in Scala and in every other language, this is not really an issue, right? So you have a syntax for creating structs, basically, right? Dumb objects. So here's the syntax for Kotlin. I'm just going to create an object, and I'm going to say that this is an ID field. I've got a constructor. This syntax that you see me using here is a constructor. And if I want to use these variables, I can inside of an init function. I can say the ID is ID, right? And the name is name. But these are not actually, these are just constructor parameters, and I can only use them inside of here, basically. If I want them to be stored in the object, I need to give them a prefix. So val in Kotlin tells the compiler that the variable is read only. It's final, basically. So you can see val. And this will mean when Kotlin sees this, it'll create a class that has getters, not setters, just read only, right? Read only. If I want mutable data, I can create properties with var. And what this will do is it'll create a setter as well. So I have a getter and a setter. It's more Pojo-like. Okay. Now I still don't have a equals and hash code and toString and all that, so I can use this in Kotlin to do that, right? So there we go. This is my new custom object. Very, very simple to understand. And the next thing that I want now is an interface. Okay, so I'll create an interface, customer repository or customer, let's say, service. And here I'm going to have a method to get all the data from the database. Okay, customer, very good. And I think I chose H2, but let's see. Let's make my life a little bit easier and get the Postgres driver instead. That way I don't have to re-specify this. We'll go back to the build, hit paste, comment this out, even reload project. Okay, so now we have an application, we have customer data. Let's read the data from the customer. We're going to create an implementation class, JDBC customer service. And here I'm going to extend or implement the interface. It's the same syntax for both. I use colon. I don't have implement versus extends. So in this way, it's very similar to C and C++, C++ and C# and so on, right? You have one unified syntax for that. And then I want to override the function. And here I've already got some interesting things happening. Look at this. It says to do. This to do function, remember, I'm expected to return a collection here. And yet the compiler seems very happy. There's no errors here. And the reason is because I have this function. Why does this tell why does the compiler not care about the lack of a return value just because I have this? What happens if I remove this? Oh, now I've got an error, right? Very interesting. Well, to do is a function that returns nothing. Nothing is the same as void. When you compile it, it's the same as void. But at compile time, this tells the compiler something very interesting. It says this function will not return. It's not that it returns nothing, it's that it does not return. So it'll keep going. So just like in Java, if you have a while loop that just says while true, or better yet, if you have a throw exception, the compiler doesn't complain if there's nothing after the throw exception, as long as it's not like an if else, right? The compiler knows that you will never reach that line, and so therefore it doesn't matter if there is a return value. Well, the same thing is here, right? If you have a function that returns nothing, the compiler does not care if you never do anything here, because it will never reach there anyway, right? So this is a very convenient thing, just a very small thing, but I think it's just a very interesting thing you can have there. Okay, so we're going to use our JDBC template, but this JDBC template, I don't want it. I want it to be stored as a field, but I don't want a getter. I don't need a getter for the object. So I'm going to use a property visibility modifier, private. Okay, so JDBC template, and I'll read the data. And this is pretty trivial. I'll just say equals dot query select all from customer. Okay, and so I'm just going to read data from this database, and my job is to turn each record that comes back into a Java object. I need to map that Java object, and you can see this the contract for this function is string, and then or better yet, sorry, query, right? It's string, and then one of these is it takes a string and then a row mapper. So I could do this. I could say row mapper of customer, and so on. But there's several things that are wrong about this. First, well, let me see, customer. So this is what it would look like. I'd say rs.get int id, rs.get string name, right? And that is okay. It's fine, but there's several things we can do better. First of all, there's two parameters here in this functional interface. This interface is 18 years old. It's been around forever, but the contract works nicely as a single abstract method type in Kotlin. And the contract says that there's a result set and an integer. We're not using that integer. So here, the compiler says you don't really need that. You can just drop the variable name if you don't care. And the other thing is, I've got this explicit functional interface type. I don't need that. And the other thing is that in Kotlin, if you have a lambda, and that lambda is the last parameter of a function, it can live outside of the method parameter here, out of the function invocation right there. So now I can hang it off the side, kind of like a Ruby block or something like that, right? So now I've got a customer service. Let's go ahead and create an object to read that data, okay? Now I'm going to go ahead and inject. I'm going to go ahead and create a bean that reads, that uses that customer service to read the data from the database. And I want to have this bean registered and start up at runtime. I could use Java configuration. I could say fun init, and I could do an application listener, right? Application ready event. I could do all of that if I wanted to, and that would be fine. But in Kotlin, it's a nice language, Kotlin, for DSLs, and so there's this nice DSL here, right, where I can have at the end, I can have as the second parameter for this a lambda that returns unit. And the lambda, you can see it's a very interesting syntax. It says Spring application dot. What that means is that when I run this lambda, when the lambda is executed, it will be in the context of the class called Spring application. So if I do this dot, it'll be as though I am writing a function inside of Spring application. Okay, and so we can provide this lambda, but look, now I can do all of this, right? This dot add initializers isn't from up here, it's from Spring application dot. And I want to create an initializer to programmatically register beans. So I'll say beans, okay? Nice DSL. There's a way to do this in Java, but it's not as nice as that, right? So there's a bean, and I'm going to create a bean of type application listener. Okay, application ready event, and I want to get a reference to the customer service, so I will say ref customer service. Now notice what I'm doing there. I'm saying just ref, and then the type. I don't provide a class literal. I don't have to do this, right? And the reason is because in Kotlin, we have kind of, sort of, reified generics, right? Kind of. So remember, at runtime, Java doesn't know what T is. If you have a list, list of string, right? This is a list behind the scenes, list of string. But how do you determine what the type is at runtime if you have only reflection, right? If you use reflection and you say, what is the generic parameter, T? It doesn't know, right? So the trick that people do in the Java ecosystem is they pass around a type token like this, right? So you'll always have .class references all over the place. It's very ugly, but it's a compromise that we had to make to support backwards compatibility. I understand why we have it. It makes sense, obviously. But in Kotlin, they've given us a bit of a band-aid that makes life a little bit easier. And that is, you can have certain functions that are implemented as sort of macros. So when you call the function, the compiler takes the definition of that function and pastes the definition. It copies and pastes it into the call site of the function invocation. So here, I have a function called ref, right? And ref is a public final inline function. And because it's inline, it's like a macro. And because it's inline, we can use reified T. So reified T means that the compiler will basically capture a type token. It'll capture customer service.class, and keep it in the bytecode at that site so that I can do this. I can say ref customer service. The type is enough, right? And so if I look at this type, this type that I have back here, this result is a customer service. It's redundant to specify that, so I don't, but that's customer service. So I can now look up beans that way, and I'm just going to print out the result. I'll say for each, and then I'll print line it. Now the other thing is I'm using a lambda here, right? Remember what I said. If you have a lambda at the end of the function, it can live outside of the parentheses, right? So I could do that. Get rid of it too, right? I also have a string, right? And I can use a feature from Groovy where I can just say, no, I want to use the implicit variable name called it, okay? So this is a very nice example. We have a DSL for functional bean definitions that works very nicely in Kotlin. You can see we've got, every little thing here. We've got reified generics. We've got very nice syntax for registering lambdas. I mean, just lots of little things that make life easier. Okay, let's go to our configuration property files, spring.datasource.url, JDBC, Postgres, QL, localhost orders, username, JLong, password, orders. Okay, so that works. That's fine. There's our data. Some data in the database. No big deal. Now, this is a very simple example, but it showed us already that these APIs are old. JDBC template, that's 18 years ago, right? And yet it's easy to use. I can benefit from Kotlin even with older APIs, and one of the reasons I can do that is because Kotlin makes it easy to package extension functions. These functions live in the same jar as your Java code, but they add new functionality to much older types. So we can build native Kotlin APIs for Kotlin community users that are, it's kind of like a secret level, right? It's a secret level in a video game where you have an advantage. And so these extension functions make life easier. They adapt old functions to new styles. So here, JDBC template.query for list, and if I wanted to do that one, here we go, list law, and I want to pass in customer. Is that it? What's a good one? JDBC template.query one. That one. There you go. See that? I'm trying to call a function, and it says, do you want to import org spring framework JDBC core query? Yes, please. I command click on that. You can see it says this function, public fun JDBC operations.query. I'm adding a function to an existing type. So now all the instances of JDBC operations in the JDK now have access to this extra function that isn't in the core Java interface. And these functions make life easier if you're using it from Kotlin. So in Spring, we have a whole bunch of extension functions, extension APIs that make life even easier for Kotlin users. So we've looked at now how to take old APIs and use them from within Kotlin. I know I'm running very short on time, so if you'll just give me like just 5 more minutes here. Let's look at one more thing, okay? One more really nice thing about Kotlin, which is the ability to use it with DSLs. So we've already seen some of that. We already saw that we have a DSL here that makes life easier. We saw how extension functions work. I'm going to go create a new application, start.spring.io, and DSLs. And we're going to use the reactive web support. We'll use Postgres. And I guess that's it. Maybe we can use Gateway. We don't have enough time for Gateway, but I'll add it just in case. So reactive web, Postgres, and R2DBC, which is the reactive relational database connectivity abstraction. I'll hit generate. UAO DSLs. And this is going to show us, I'm going to show you that we have new APIs in the Spring ecosystem that were built with Kotlin in mind. So JDBC template was, again, 18 years old. It has been there for a long time. It came before Java 8 Lambdas. It came before Kotlin. It came before Scala. It came before everything, right? So the fact that it just works so nicely is a sign of Kotlin's flexibility, right? But now in Spring, the team have, oh, that's Java. Yeah. Awkward. So RMRF DSLs. Team have worked really hard to make Kotlin a first-class citizen for lots of projects. So we have shipped separate DSLs in various jars. So Spring Data, Spring Security, Spring Cloud, Spring Boot itself, Spring Framework, Spring Session, Spring Integration, just everywhere, right? There's different APIs. So we're going to create a very simple application here. And we're going to use some reactive APIs. Now, reactive APIs are non-blocking APIs that scale much better, okay? So I'm going to say interface, customer repository, and this is going to extend the reactive CRUD repository. And it's going to have an integer. And of course, in order for that to work, we need a data class. So data class, customer, val ID, int, val name, string. And of course, we need to give this an ID property. There we are. So now I've got my repository and I've got this Java int. I don't want that. I want just a regular Kotlin integer. And what I want to do is I want to create a bean that gets called when the application starts up. Did I also add Webflux? Yeah, I did. Good. So I've got this beans initializer. Good. I'm going to create another bean here. And here I'm going to create a bean that starts up application ready event. And I just want to use, again, val cs equals ref customer repository dot find all dot subscribe. So here I'm getting back each record, and I'm going to print out the results, subscribe, like so, okay? Print line it, that's fine. And what I also want to do is I want to register a HTTP endpoint, and I could use a controller, but again, there's this functional style, so let's use a router instead. I'm going to use a functional reactive router. And here, I can add a router very easily using this nice DSL that's in Spring Framework 5, right? So customers, here we are, and you just return the response. So response, server response, .ok.body. And the body will be the data from the repository. So it's ref customer repository. And I'll say cr.findAll. That works fine, right? And again, I've got an extension function because normally this function takes a class literal, but I don't need to here. But what about this data? What about if I want to get the customers by a particular ID? Well, here, I need to get the data, and I need to dereference the ID from the path variable, right? So ID. I'm going to turn this into an integer. I'm going to use that here. I'll say, okay, give me cr.find by ID, val response. And the thing is, what I have here is a reactive type. Okay, so it's a reactive type. So I need to use that.
Dear George, sorry to interrupt you. You have only 5 minutes left, and
No
the
problem.
one question in Q&A session. Sorry to
Okay.
interrupt you.
Thank you. So we're gonna have a single response here. I'm gonna provide a response by passing that in. And that's fine, I guess, but what you have to understand is that behind the scenes, this is a reactive type. It's a reactive type of data. So I've got a wrapper that wraps the type that I'm trying to send. It's like a completable future. But sometimes this might be difficult to understand for some people, right? I think it's okay. I use reactive programming all the time. But in Kotlin, there is a different choice. There is the ability to use something called coroutines. Coroutines help you write asynchronous code which looks like it's imperative, straightforward code. So rather than having to constantly chain together operations in a functional style like this, and rather than having to think in that way, you can use coroutines to think about very imperative style code. So in this way, but in order to use this special compiler feature, you need a root context somewhere in the code where everything inside of that is coroutines, okay? Well, in Spring Webflux, you can just use our co-router, okay? And so once you've done that, you can also await. So I'm going to say await, and that's going to give me a customer, right? But what you need to understand is that we're not blocking. At no point am I sitting here, checking the time, waiting for the data to arrive. I ask for the data, and then behind the scenes, the compiler stops this thread. It gives the thread to something else in the system. And then at runtime, when the data comes back from the socket, then this thread is restarted and put to work. But that thread is freed so that something else in the system can use it. So now I've got this customer, but I didn't have to write this very complicated asynchronous code. So now I can say, okay, response body await, right? There's that. And then for this, I need to use a flow, right? So again, extension functions to turn reactive types into things that the runtime will know. So body, so flow, body and await. That's right. Okay. And what is the issue? Body value and await. Okay. I've got a functional reactive HTTP endpoint, and I'm writing imperative style code. I'm not really thinking about control flow being any different than I would expect normally, but I'm getting the benefits of the most well-written, most efficient kind of code. Okay, let's see here. So I got to do this again. So R2DBC password is orders, I think. Isn't that what I said? URL is R2DBC Postgres localhost orders. And then the username, stay along. All right. Okay, so we go to the browser, localhost, customers, there's our data, etc. All right, my friends, I want to thank you so much for your time. I wish I could have been there in person. It's a shame that we are all separated from each other for so long, but maybe if we all get the vaccine and we're okay, maybe next year, who knows? I hope we get to see each other and I hope we're safe. Thank you so much for your time. I appreciate it. And I hope you have a wonderful day and enjoy the rest of your show.